Good evening, everybody. Welcome to the summer 2016 session of Advanced Programming with Java. There are a lot of you out there. So I think, as you've seen in some of the emails that I've sent out, this is the first time that we've offered this as a co-listed course. So there's both an undergraduate and a graduate section. And I think, as many of you are aware, the course filled up very quickly, and there are long waiting lists. This is a new situation for me, and I have to admit, I don't know how to navigate all of the university's policies around the wait list and who gets in and who gets out. So I do know a couple of things that I'll share with you. The department was very clear with me that they would like me to record who's here tonight, and anyone who's registered for the course who did not attend here and who already didn't contact me beforehand will get dropped from the course to allow people who are on the wait list to join. So that's what I know, and so my hope is to by early next week we'll know who exactly is registered for the course. I'm also going to count the cards tonight to figure out how many of you there are exactly, so I can figure out if I can reasonably accommodate anybody else in the course. I mean, there are a couple constraints there. One is the physical size of this room, not only for this sort of eyes forward style of learning, which we'll be doing some of, but one of the things I really like about this classroom, one of the things that I want to leverage in this course are the projectors around the center of the room. So those of you who have checked out the course, maybe talked to students who have taken it in the past, we do a lot of pair programming and mob programming, and this classroom is ideal for that. I don't know how ideal this classroom will be, though, with so many of you, both in terms of just like physically getting people around in areas and also the noise of having however many of there you are. Oh gosh, there are like 70 of you out there. All talking at the same time. So we'll do the attendance and everything like that sort of at the first break or something. Oh yeah, hi, I'm David Whitlock. I've been teaching this class in one form or another for almost 16 years now. I started teaching here in 2000, and back then Java was kind of the new programming language. It was only a couple of years old, and it was new to PSU. I had just gotten my master's degree and I started teaching it. And Java has evolved a lot since then. The course has evolved a lot since then also. So originally, this was a course about Java, about the programming language, about the APIs. It was really focused on that. But over the years, I found a couple of things. One is that by the time students get to this course, you've seen Java in other areas. Maybe some of you have used it in your compiler's course. I think everybody gets a couple of weeks of it at the end of 202 or one of the lower division courses. And also there were more topics that I wanted to cover than just the language and what the API is and what you can do with it. And so the way the course stands right now is that it's really not so much a Java course as it is sort of advanced and more contemporary topics in programming, and we're using Java as the language, a number of the Java tools, the Java ecosystem to express that. So I hope a number of you have, or most of you have seen Java before, have done some programming in it, and specifically as far as what we cover, I'm not going to be teaching you about the Java programming language. I have resources about it. We'll be using Java. You'll be seeing a lot of it. But you guys have learned programming languages before. Hopefully you know how to learn another one if you're not familiar with Java. The references are up there, and of course feel free to ask questions that you might have about the various language constructs, especially some of the newer stuff. Some of the Java 8 and Lambdas probably wasn't part, might not be something you'd seen before, but maybe they have been, so surprise me. Let's see here. I'll dig into the syllabus in a little bit, but I just wanted to introduce you to this, which is the course website. It's my homepage at the CS department. It lays out everything that you need to know about the class. It's organized by week. In this course, okay, it's another course note. So when I started out teaching this course, it was very much eyes forward, sage on the stage. Come and listen to me pontificate and read slides to you for 2 or 3 hours once a week. And after doing that for about 10 or 12 years, I realized that I was getting bored of that. And if I was getting bored of that, it was something excruciating for you guys. So I took a step back and I said, okay, well, what do I really want to get out of the course? What do I really want for you? How do I want you to experience it? And I decided that while it's fun for me to be up here on stage and tell jokes and for you to feel obligated to laugh because you want a good grade, it's not necessarily the best learning experience. So what I've been experimenting with what I experimented with and what I decided is good for right now is sort of an inverted model. Tonight I'll be doing a lot of talking. This might be some of the most talking that you hear me do. Really the sort of the book learning or learning the material, I want that to happen outside of the classroom. So what I've done is I've recorded all of my lectures, and so these are the same slides that I used to give live. I recorded them all, put them up on YouTube, and that allows you to watch them at your leisure, at your pace. And so then if you need to pause it for a little while because you're feeling nauseous or bored or whatever like that, you can do that. And you can also fast forward to the parts that are interested to you. You can do that on your own time. As a matter of fact, I expect you to do that before class. So the way each week is organized is that there's a handful of screencasts that are up on YouTube that I encourage you to review. Please feel free to ask questions about them. You can post on YouTube if you want, or you can use some of the other methods of communication that we'll talk about. So that's what. And also there is a textbook. To be honest, it's at best a reference, and it's really old, but it's free. And so then if there's another Java textbook that you like or something that you can recommend, please feel free to use it. But the nice thing about Java, and I guess really you guys have experienced this, the information is out there. It's free and it's available. And also, for this course, and I'll revisit this more in the syllabus, I don't mind if you do Google searches to figure things out. I don't mind if you do Stack Overflow, but caveat emptor, sometimes the stuff on Stack Overflow isn't as expert as they make you believe. And ultimately it's up to you guys to learn the material and to do it. So I'm not going to say that it's cheating to go look for some other answer. I'll be really surprised if someone has posted a complete answer to the assignment, implementation of the assignment up on the web. So let's see here. What else? Oh, and I guess also, so that's what you do before class. In class tonight, it's sort of a lot of one-way communication. We'll talk about the syllabus, lay out the first couple of projects. But really, what I want to do in class is show you how I program to help teach you some of the things that I think are good for you to know. And so we'll be doing a lot of test-driven development. You'll be seeing me type and use the IDE, use IntelliJ to build the applications. And what I'll do is I'll instead of thinking in my mind, I'll run my mouth, and so you'll get to bizarre insight into my thought processes. We'll do that sort of at the beginning, and that's a one-way communication. And then starting next week, we're not going to do it tonight. We will break up into smaller groups to then implement what are called code katas, little programming lessons that take, I don't know, half an hour, 45 minutes. And we'll do that in pairs and small groups mob programming around the edges of the room. Any references or things that I talk about are here up on the website. Some of them are handouts that I've developed. And other things are just good links that have to deal with the course. I also highly recommend that you check out this series of screencasts that Jim Shore, Portland's own Jim Shore, has put together on test-driven development. It's really good. It's kind of a thing, though, that you don't want to watch all 27 episodes at once. It's sort of every day, or I recommend 4 a week. He develops an application, and you really get a good insight into what it means to do test-driven development and how you can watch the application evolve. And I think that's unique, and I think it'll give you some good ideas for how you can apply it to your own code. Also, so again, not only do I have screencasts of the lecture material up on YouTube, as you probably noticed, I'm recording the in-class stuff. And so, I have a screencast of what's here on my screen, and it'll capture the audio. So if you want to relive the magic or, put a dance mix behind it or something. I don't know. Or probably more importantly, if there's something that you want to review, or if you're not able to make class, I will post this stuff up to YouTube. I try to get it done before the end of the week. So I want to make sure that the class is accessible to all of you. And also, we teach in the summer. Some people have vacation. Some people, get hay fever or whatever and can't always make class. I used to have this joke about Felicity being on Wednesday nights, but it's been a long time since Felicity's been on. Yeah, okay, some of you remember. Yeah. But anyway, so I want to make the material accessible to you in a format that works for you, and so that you can revisit and participate in the class when it makes sense for you, because it's cheap and easy for me to do so. Okay, that's the format of the course. Any questions about what sort of this physical stuff looks like? Let me dive into the syllabus, and maybe that'll spur some more questions. So you've got it there in your handout, so please turn your hymnals page 1 for those of you playing along at home. Okay, the syllabus. It's a college course. I need fancy words like syllabus. Okay. So what are we doing here? Ultimately, what I'm looking for out of the class, and what I hope that you get out of the class also, is to learn about Java, the Java programming platform, the Java ecosystem, and to have some fun doing it. I enjoy writing Java programming and Java programs, and wow, there are a lot of you who have expressed interest, and I hope that by the end you'll enjoy doing it too. For those of us who've been doing it for a while, there's been a lot of evolution in this space. Java, in some respects, has sort of been the first, it's been the first internet programming language, both in terms of what it offers you can do, but also then how it's developed. There's been a lot of open source software developed in Java, and so then it sort of has become, in many parts of software, sort of the lingua franca of what we're doing. So and as a result, there's lots of cool things that can be done with it. So I've already talked about this. Here's how we do it. We have online lectures. We'll have in-class discussions and pair work. I'm a big believer in putting code up in front of people to teach them. So it's not just about learning the syntax, it's about learning the idioms of the language and how you do work in the language. And so you'll be seeing a lot of code. I've provided you a lot of code up on my GitHub site. As far as the work that you contribute back to the course, there's a multi-phase project. We'll be seeing project 1 tonight. It does build upon each other. So in the first project, you'll be laying the foundation, really sort of getting yourself used to the tools and running unit tests, integration tests, good stuff like that. But then each phase of the project builds upon it a little bit. And then we also have quizzes and exams. The quizzes are on D2L, and we'll get to that a little bit later. And then, well, there's not a midterm exam, but there's a final exam. What are we going to talk about? Well, actually, we're not going to talk about the Java language syntax and object-oriented design programming explicitly. You'll be seeing a lot of it, though, in the code that we write, in the discussions that we have, as we learn about refactoring, good stuff like that. We'll be learning about the standard Java class libraries. So I don't know how much you've dug into the standard libraries, the STL and C++, or actually probably if you've done anything with Python or Ruby, you've used the libraries. But this is an important part of programming with Java. Java has a very powerful set of standard libraries doing things like I/O, grouping objects together, that not only are very useful, but they can show you some good patterns and in some cases some anti-patterns for object-oriented programming and just writing Java in general. One of the things that I find is really important and has actually kind of become a differentiator for this course is testing and automated testing. So I've been teaching about unit testing for a while now, but over the last couple of years, as I've really delved and internalized test-driven development, I realized how important testing is and how valuable it is to software development and to software engineers, especially people who are just starting out and sort of need to maybe improve themselves or just want to be confident that yes, what they're doing is working and working correctly. We'll also look and leverage the Maven tool for building Java projects. Java projects can get pretty complex, especially when you're dealing with lots of source code and lots of third-party libraries. So all of these great frameworks for unit testing and for what else do we use? Well, mainly unit testing, I suppose. But you'll see some and web development, all sorts of stuff like that. Requires lots of third-party code to be downloaded and coordinated, everything like that. Maven takes care of all of that. We'll also be talking about developing applications for the web because people do that now. There are really two sections to that. The first is I sort of consider it web fundamentals. We'll be learning about how to build web applications in Java using the Servlet API and using web containers and good stuff like that. There's a little detour through the dependency injection pattern, which helps you manage large applications and the dependencies among objects and classes in those applications. And then finally, we'll end the term with a discussion of rich internet applications. And we use a framework called Google Web Toolkit, which admittedly is getting a little bit long in the tooth, but the reason I do like it, and the reason that I think it works well for this course, is that it allows you to use the Java programming language to develop web applications end to end. So not only the stuff on the back end, like doing all the server-side processing, but you can also develop the web side. It has magic compilers that take the Java source code, turn it into JavaScript, and CSS can be executed in your browser. It's a very accessible way of writing rich internet applications, and it fits in very well with the course. And you can also do some nice object-oriented patterns. There's also good patterns for testing and stuff like that. So that's a lot for 8 weeks, and so we go pretty fast. There's a lot to cover, and that's why it's a 400, 500 level course. Yeah.
Are we going to touch Android at all?
We're not going to touch Android. As a matter of fact, and don't hold me to this, I'd like to go there next, but first I have to learn it. So I try not to be one of those professors that just is 1 week ahead of you guys in the textbook. I try, but yeah, I think that would be a better alternative. I know a little bit about it. I just need to figure out how best to incorporate it into the course. So maybe next year, maybe the year after that. We'll see. Okay, grading policies, because there are grades. So for me, what I want you to focus on in the course, and so therefore what I'm going to assess you on, is the code that you write. So the largest percentage of your of the grade is the multi-phase project. That's 60% of your grade. Each project gets worth progressively more. So I don't know, it starts at 8 and goes to 15 or something. There will be 8 quizzes, and there are 8 weeks in the course, so it's basically a quiz every week. It's up on the website. Each of those is worth 4%. 8 quizzes with the lowest grade drop. So if you forget to do one, or you're having a bad hair day, or whatever, we'll drop the lowest one. That counts for 28%. Like I said, those are on D2L. Oh, and note that 2 of those quizzes are surveys. There's a midterm survey and end of the term survey. That are a little more difficult to navigate to in D2L, but there should be the reminder notices and everything like that. And then your final exam is worth 12%. So your grade will hopefully not be determined by your final exam. This is not one of those courses where you can just sort of show up, cram for the midterm, cram to the final, and get an A. Sorry, that's not the kind of course I want to teach. There is work due in this course every week. And so then, please consider that as you approach the course and decide, whether or not you want to come back next week. There are 2 late days that you can have on project submission. So sometimes, there's you can't get the get the project due on time. Projects are all due right before class. Meaning that I want you in class on Wednesday at 6 p.m. I don't want you in the lab or at home finishing up your project. So projects are due before class, so please come to class. If you do submit your project after the due date, that starts the timer on the first day. So that takes up the first day, and you get 2 of those during the course. Sometimes you have it's like a fundamental bug in your project, and every test case fails because I grade them automatically. I have the grader. I got people for that. I have the grader grade them automatically. So in case like yep, you missed a requirement or like the misspelled a command line pattern or command line argument or something like that, you can submit one project for regrading within a week of the original grade. So like you receive your grade and you're like, oh no, I got everything wrong. Quickly fix it and turn it back in, and that won't count against you. You get one of those. Otherwise, my policy is no other late work will be accepted. That's the policy I have on paper. I want you to be successful in the course, and of course, things happen. During life happens. If there's, if you're concerned about something, if you have like a family emergency, or whatever, let me know. I have flexibility. But in terms of like, for the lawyers, I have, these policies in place. I don't want anybody saying, but you never said I couldn't turn in project one on the last day of the class. Well, okay, good deal. Because I've had that happen. Can you believe it? Yeah, anyway. Okay, I grade on a curve, but as I've seen over the years, there's usually not much of a curve. So maybe that means I'm doing something right, or maybe I'm just lucky, or whatever. So and also I've had the situation where because it's mostly programming, and you're probably pretty good at programming, a lot of people do really well in this course. And so then there have been a couple of students over the years where they sort of see their number grade and see their letter grade. It's like, well, but in this other class I got this number grade, and that was considered really high. How come it's not an A here? Because it's like, well, because look at the curve. So just sort of like be aware of that. So like if you're sweating your GPA or whatever and want to make sure and you're hoping for an easy A in this course, it's probably not the right call for you. Okay. I had to adjust the syllabus because we have these two sections now, and here again is my first time doing it, so I don't know if I'm going to get it all right. So the content and the grading policies are the same for the graduate and the undergraduate section. I just found out there was going to be an undergraduate section a few weeks ago, and I'm emailing with Warren, and I'm like, I don't have harder projects ready. What am I supposed to do? And he's like, well, hey, you can have the same product. So you're getting the same project. So it's essentially the same course. You basically either get graduate credit for it or undergraduate credit. And so the grading policies are the same, late policies are the same. They'll both be graded on a curve, but I'm going to grade the sections on a different curve. That seemed fair. So I'm not, so in terms of, a score of 90 might be, a B, it might be an A minus on the for the undergraduate. Oh, but maybe it'll be a B plus on the graduate. I don't know. We'll see. Or maybe the other way around. I don't know. Just saying. So anyway, yeah, this whole two sections thing, I'm still sort of feeling out, trying to figure out. So it'll be a different curve. So I'm not going to assess. I'm going to assess you guys equally, but in terms of the final grade, which is what shows up in your transcript and goes on your permanent record, all that good stuff. There'll be separate curves. I don't know why I had to say this, but here again, it's like if I don't tell people not to cheat, they're like, you didn't tell us not to cheat, so anyway, don't cheat. I don't have a problem. Rather, I haven't had a problem with cheating in a very, very, very long time. I think I can only think of like one or two instances over the last 16 years because you're fundamentally good people, right? However, I have a tool that makes it really easy to determine if anybody's copied their stuff. It's this really cool tool developed quite a long time ago now out of from Stanford called Moss. It's really smart. So I'm sure like all those people that wrote it are now like designing algorithms at Google and stuff like that. So it's good. So don't copy other people's work. Guidelines though, because on one hand I'm telling you collaborate in class, pair program, work together, everything like that. That's awesome for class. If you are working with someone, I guess what my policy is feel free to talk, draw pictures, maybe glance at somebody's code, but don't copy anybody's code, right? And yes, so you've all been doing this long enough. You know what cheating looks like. You know what cheating feels like. Just please don't do it. Okay. Well, let's see here. Lecture notes are available. If you like hard copies, print them out yourself. Feel free to bring your laptops along also, because Facebook happens while you're in class. Advice from many students past: don't wait until the last minute to start the projects. They might look straightforward, they might look easy, but I've had students tell me it's like, oh yeah, right, it's a little more complicated than I thought. So Excellent, and we'll talk about next week about some of the mechanisms that I had to prevent that. Uh, we'll also talk about documenting your code and the importance of it and what that looks like. There's some amount of documentation required for the course. There's a portion of your project grade that has to do with documentation. So I recommend that you document your code as you write it. So if you can say it in Java, say it in English first. So please feel free to, actually not feel free, I request that you ask questions. I know this stuff. I enjoy hearing the sound of my voice echo off the wall and coming back here, but I could be doing that, out on the street. I'm here for you. You're here to learn. You're paying to learn. If there's something that you don't understand, if I'm going too fast, if I've done something, you're just like, what the heck you just did? Or if I did something, it's like, wow, that sounds really neat. I want to explore that. Stop me. Raise your hand. Yes, it's a big class, but I want to make sure that you get what you want out of the class. And I think I've also found over the years that if there's something I said that you found confusing, probably other people found it confusing also. And so you're actually doing not only yourself, but also your fellow students a favor by asking for clarification, by making sure that I'm communicating effectively for you. Senior level course, it's hard, there's work. Please manage your workload. Yes, the summer, I know there aren't that many other courses offered, but if you're taking lots of other programming intensive courses, operating systems compilers and stuff like that, don't hurt yourself too much. Like I said, there's lots of code. They're for you. Go home, play with them, modify them, use them for ideas for your projects. That's what they're there for. I hold my office hours. I probably got some office here in the building. I'm sure it doesn't have natural light. I've never used it. I might even have a phone. I don't know. I work downtown during the day, and my office hours are the hour before class at Hot Lips Pizza. So come have dinner with me. Sorry if you have to watch me eat, but that's if you want to talk to me, that's the best time. I'm also available on email. I use Google Tools a lot because they work. So I'm available for Google Hangouts and stuff like that. If you have a question, about the assignment, I found that works really well. I usually don't have like set office hours, but if that's something that enough people want, I can probably accommodate it. In terms of how I will share with everybody here, I use a Google Community. This is Google Plus. For the class. Don't type in that big URL. You can click on it. It should be a link. Anyway, please join it. Through your pdx.edu Google account, you can sign up, and I found that works pretty well for this broad communication. And also, please feel free to post questions that you have too, especially questions that you think might benefit others, or if you're talking with someone outside of class about it. If you both have a question, put it up there. Because here again, if you get the question, you're probably not the only one. I mean, it's a lot of averages, right? There are like 400 of you out there. Okay. You can also email me at the cs.pdx.edu email. All of it goes to the same place, and so I get it eventually. There's the class webpage. We were just looking at it. And also, it's funny. I was looking at it here, and when the first time that I taught in the fall of 2000, we were over at the old. Does anybody remember the building that was there before they built the rec center? The really old, ugly building built by the phone company, like back in the 50s, with like this like blue tile. Oh, it was awful. It had this really like creepy courtyard in the middle that maybe at one time was lush, but all the trees had wizened up. Anyway, I was in there. The roof leaked. No, okay. Anyway, I was in there, and my first time teaching, big cavernous lecture hall, and I had no idea what to expect. And I get there, and there are probably like 70 people in the room. I'm like, what have I gotten myself into? And you know what? I really shouldn't have worried, because by about week 3, we had 18 people left. So I wasn't very good at teaching back then, but for some reason the department asked me back, and I've gotten a little better. And one of the ways that I've been able to scale up this course, though, is through automation. So, like I said, the projects are automatically graded. I have a bunch of scripts that grade them. I've also developed a bunch of tools to like import the grades and get stuff out of D2L and everything. And that's how I'm able to support so many students with just one grader and still get all of the work done. And one of the first processes in that workflow is that I want to know who you are and a little bit about you. And to gather this information, I've written a Java program for it. And it's the survey program right here. So what I'd like you to do after class tonight is log on to one of the CS machines, either the Linux machine or the Syllabus machine. If anybody's, I still use the Syllabus machine, but then I'm old. And run this program. It'll ask you a bunch of questions, who you are, and like what your major is, and et cetera, what your your student ID is. Sorry, your login ID is. And then it sends an email to me and copies you, and it generates a little XML file, and that's how I know who you are. I import that in my grade program, and I go away. This is a really important and crucial thing that you do because I can't record any of your grades in the system that works for me until you do so. And it also makes sure that you've got your environment configured correctly to run a Java program. So please do that, and actually feel free to do that now while I'm sitting here droning on. So, that was a half an hour. Okay. So, any questions about the syllabus, about the course, before we start digging into some content? Yes?
So, with the curve for the graduate section,
yep.
I was wondering, is it possible for all graduate students in the course to get a B- or better?
Is it possible for all the graduate students in the course to get a B- or better? Flippant answer, sure, it's possible. I don't know. It depends on the curve. I think, well, so here again, based on the undergraduate curves, there are, in the past, there have been, let's say it's the, bottom 3 students that don't turn in their assignments, that, haven't shown up for class, haven't done the work, that don't take an incomplete, they get like a C or lower. So my guess would be that if you do all of the work, and that the curve, so do all of the work and you'll get at least a B-. I can't make any guarantees though. I don't know much about the graduate rules. Is there like do they like kick you out of the country or something if you don't get a B-? Is there like you gotta take the course again? Doesn't count. Wow. So it's like the same as failing?
Correct.
Wow. Why don't they just call it an F then? I don't get that. Grade inflation. Kids these days. I don't know. Okay. Thank you. That's good. If there are other okay, here again, I apologize. I've never taught graduate students before. I'm not sure qualified to teach graduate students, and I'll let you be the judge of that. If there are things like that you're worried, thank you. That's good for me to know. And maybe I should ask Warren if there are other things I should know before teaching graduate. Don't use off-color jokes. Okay. Yeah. Let me know those things. Thank you. I'll take that into account. So here again, no promises, but I want to make expectations clear in terms of what I expect. I expect you to do the work, and for the undergrads in the past, the undergrads that have done the work have gotten fine grades. Great. Yes.
What kind of material? Like, what should we expect when we get a quiz or take the final?
The quizzes and the finals are short questions. So it's like, tell me something about Java. Right? And it's not programming. There might be code snippets. I think there's one question that's like, write a function or a method that does this. Okay, that's about the extent of it. Any coding will be part of the quizzes. That'll be part of the projects. Really, the quizzes and the final exam, they're qualitative. So it's for you to express in words into English what you've learned in the course. I feel it's important to assess that, but it doesn't count nearly as much as writing code, as what it is that I hope you learn in this course. Okay, anything else? Not enough of you have run to the door yet, so let's get going. No, you have a question?
We'll have a relatively week
Yes. Wait, some weeks you have 2 projects. Yeah, so let's take a look at that. Because here again, I'm not kidding about the workload. So tonight we will be seeing 2 assignments. Project 1, which we'll talk about shortly, and then the cones. And let's see here. Each project is due 2 weeks from its assignment, but there's a new project every week. So meaning that next week, well, there are no projects, but then project 1 is due in week 3, but then you also get project 3. So dig me, right? You got it? Okay, good deal. I gotta do the hand thing because I don't understand it. Okay, yeah. So yes, there is essentially starting week 3. There's a project due every week. A new project is added. So you've got to manage your work in progress, right? You've got to stay on top of things. It's an 8-week course. It used to be an 11-week course. I shrunk it down for the summer, and so we go to clip. It's also advanced, so why not? Yeah.
You have project 4 due 2 times.
Oh no. Okay.
Is it BJ or
It's whatever it says in the assignment. So let's see here. What's project 4? Okay, project 4 due. Oh yeah, that should be project 5 down there at the end. But yeah, so the official answer is always in the assignment itself. So July 27th. Thank you. Note to self, fix that. Okay. Thank you.
Can we submit to multiple projects like ahead of time?
Yes, you can submit the project at any time. We won't grade it until after it's due. So here again, there are a lot of you. There'll be at least 50 of you. That's a lot for one grader. And so then, feel free to do the projects early. But we won't be able to accommodate early feedback. It's kind of a slog. Between that and the quizzes, there's quite a lot of stuff for our grader to do. Okay, anything else? Okay, so syllabus taken care of. Enough of that. Okay. You know what? Let's see here. Do I want to talk about the projects next? No. Let's watch a video. Okay. Who's heard of test-driven development? Good. Bunch of you. Have you done it at school? Is this something that, like I started talked about? A couple of nodded heads. Okay, talked about it a little bit. Okay. For me, so there is this movement at Foot that sort of has gelled in the last 4 or 5 years called software craftsmanship. And it's really a culmination and evolution of a lot of the thinking around how about the work, the craft, the art of software development. And it's really taken a lot of lessons that have been learned over the years, coupled with what is now technologically possible. And it really emphasizes a lot of practices like test-driven development and code refactoring. And one of the luminaries in this space is a guy called Bob Martin. He goes by Uncle Bob because he's kind of wacky. His presentation style can be an acquired taste, but he has a lot of good information, a lot of good ideas about how to write good code. He calls it clean code. So this is code that can be tested, that is tested, code that can evolve and stand the test of time. So, maybe you guys have seen it, maybe you've written some of it, that code that you go back and look at weeks or months or years later, and you're like, wow, who's the idiot that wrote this thing? And you're like, oh, it's me, right? Is that feeling that we want to avoid? Because sometimes the idiot's you, and then sometimes it's your coworker or somebody that doesn't work there anymore. And this is bad. This is expensive. And so and there's so much code that's been written over the years that we've really learned a lot. A lot of people had this information in their head. There have been books over the years, but really it's all culminated in the software craftsmanship movement. As far as what I want to talk about and focus on in this course is the test-driven development and the refactoring parts of it. So let's get an introduction to that by watching this brief video from Bob Martin. This comes from a series of videos that he does called the Clean Coder videos. If you're looking for a holiday gift that isn't a sweater from some distant relative in the Midwest, ask them to get you a subscription to this. It's probably a little cheaper than the price of a textbook, and I think way more valuable. Anyway, this is a little 5-minute snippet where Uncle Bob talks about test-driven development and introduces this red-green refactor cycle. Oh, and you know what? It would probably help if I plug this into the audio. I forgot about that. Sorry. And I got to figure out the audio. Let's see here. Volume. Nope. No. AV mute. Auto image. Inputs. Volume. Inputs. Outputs. That's the microphone. Audio. Volume. I'll try that. Oh, wait, here's something. Turn it up. Too loud. Okay. This might be really loud, sorry.
Oh, it's time for the red-green refactor cycle. And I am in the red phase. I must write a failing unit test. All right. What test must I write that will force me to write public class game? Well, I'm going to write can create game. Game G equals new game. Oh, heavens. Thank you, IDE. Helpful IDE. That's enough of that. Heavens to Murgatroyd, that doesn't compile. Well, I must make it compile. So now, I'm going to create the class game. Yes, in the current package, there it is, the class game. And if I go back to my test, oh, look, the test passes. It's time for me to go to the green phase. I am now green. And in the green phase, it's time for me to refactor. Is there anything I can refactor here? No, nothing to refactor. Very good. Then I am done with this test. I am passing. Lovely. Back to the red phase. The next test, well, I know I want to write that roll method. All right, test can roll. Oh, heavens, I need a game. Game G equals new game. Lovely. G dot roll, what should I roll? Well, let's roll a 0. That doesn't compile. Okay, time for me to focus on making it work. I'm going to create the method roll. Ha! Look at that, roll. And it should take a pins. This is lovely. And I believe that that will pass. Because I'm not actually testing anything. Oh, time for me to refactor. I've got a passing test. What's to refactor? Oh, goodness, I've got duplicate code here. Duplicate code. Well, I better take that and refactor that out. I'll create a field named G. I will initialize it in the setup method, which of course I don't have, but this will create. I'll keep it private. Lovely. So now I've got a nice setup method. It's going to create the the game. It'll put it in the private field G. Can create game is now empty because, well, it doesn't do anything. And I think I can get rid of that line of code in can roll. And all of this should still pass. It does. I think I can get rid of that empty test now. This is common, by the way. You write a test just to delete it later. Lovely. Next most interesting test case. Back to red. Well, what can I make fail now? I got to write the score function. But I can't call score until I roll a complete game. Okay, so here we get into some of the technicalities of test-driven development. When you must write real code, you write the simplest real code you can. In this case, I'm going to have to roll a complete game. What is the simplest, most degenerate complete game that I can roll? A gutter game. Let's roll the gutter game. Okay. 4 int I equals 0, I less than how many balls in a gutter game? 20. I plus plus. G dot roll 0. That will roll 20 zeros. That is a gutter game. And now we will assert that the score is 0. Oh heavens, that doesn't compile. I must make it pass. Excellent. I will make this compile. It should return an int. I'll have it return a -1 because I still want to see it fail. It should fail. Yes. And now I will make it pass by returning a 0. This is stupid, but it's also easy. And I have now seen my test both pass and fail. I know my test works. It cost me nothing, but I now know that my test will fail if I don't get a 0. Well, that was nice. What is the next most interesting test case? Or is there any refactoring to do? No. Next most interesting test case.
Okay. Happy cutting. Yeah. Maybe they're from Sweden or something. I don't know. What did you notice about that video, other than Uncle Bob and his hat and his Homer Simpson T-shirt or something, right? What about the code and about the approach that he took? What are your observations?
It was incremental.
It was incremental.
Very small amounts.
Yes, he worked in very small steps. So baby steps to get there. What was an example of one of those baby steps? Sorry? Right. Yeah, just create. The first thing he did, it was like, hey, can I even create my class? And you think, of course that's going to work. Well, but what if it didn't? Wouldn't you want to know right away? Right? And that's why you start with something very, very simple. And what did he end up doing with that test? He deleted it. Right, because it was like fit to purpose at the very beginning, and then it had a very short lifetime. And that's okay. Other observations?
The roll method, he didn't even use the integer he passed in.
Right. So he wrote this roll method, and he knew that the signature that took an int. And in that moment, did he do anything with that int? No. He had the contract, and that he didn't implement anything with that. What do you think about that? Is that okay? Is there dangers? Is there risk there? What would happen if he didn't implement it? Yeah.
If he eventually writes a test that passes in an int and doesn't use it, then that'll.
Exactly right. So I'm sure he felt confident that at some point he will be writing. His tests will evolve to the point where they will fail because it's not implemented. So I know that one of the things that I used to do is as soon as I create a method, I try to implement it and everything. And then you get down to implementation land and it's been 5, 10, 20 minutes, an hour implementing all this stuff. And you're like, oh, wow, I've written, I spent 20 minutes writing code and I don't have a test for that. How do I know it works? It doesn't seem right. So I think it's a very astute observation that he's working in little increments, little baby steps. What else?
It's very minimalistic, sort of the constant refactoring, removing code, going for the simplest test cases.
Yep. Yeah. Minimalistic, again, baby steps, and taking that opportunity to refactor constantly. So, I appreciate the 3 different modes that you're in. The red mode, I want to get something that breaks. I'm sort of writing new code. I'm writing the test. I am capturing the behavior. I am codifying the behavior that I'm looking for in a test. So I write the test to express what I think the program should do. And then I change mindsets. Then I say, okay, great, I've got this test. What does the application, what does the code under test need to do to make that test pass? And then you implement. Implement just enough to satisfy the test. And once you run it, once you demonstrate that you've implemented enough, that's when you take a step back and say, okay, of the code I just wrote, either in the test or in the application, is there an opportunity to make it better? And since you do that, and then you verify the test still pass, what do you have at the end? You have the best code you can have right then. And if you do that all the time, the current code will be the best code that you can have. And so then, once I really sort of understood that intuitive, it's like there's a lot of power there, right? It means that you can stop. It's like when you've written all your tests and all your tests pass and all your code's been refactored, the last, so within minutes of writing your last test, you're done. You don't need to go back and refactor everything after the fact, or you need to go back and write all your tests after the fact, because you'll have forgotten all those little decisions that you made. Or you will spend a bunch of time going down an implementation path, only to realize, oh wow, that algorithm is completely wrong, or oh, gee, there's a whole different set of interactions here that I didn't think about. Well, the thing that I like about test-driven development, what I found from my own experience, is that it, oddly enough, it takes a lot of the cognitive burden off of coding. It makes it easier in some ways because you're just focused on that little baby step. But then you get to the end, it's like, wow, I took a whole bunch of baby steps, but it's like, I'm here. Yeah, it's really cool. So anyway, that's my experience. I hope this gave you a pretty reasonable introduction to what test-driven development is all about. You know what? I think we're at a good stopping point. Time for a break. Before we leave, there's something I want you to do during the break. I brought index cards. Apparently I was feeling old school, and I brought all 100 of them. That should be enough for you. And what I'd like you to do is put your name on the index card. This is me taking attendance. Put your name on the index card and also the last 4 digits of your student ID, just so that in case there are 2 people with the same name or whatever, I know who you are. And then let's reconvene in 10 minutes. I'll pause the recording. Stop the recording.